Hello everyone. Today I will talk about the importance of research, particularly with respect to our country India. Many of you would like to pursue engineering degree in the future or in the coming years, but you should keep it in mind that research is also as much importance as any other disciplines, because without research you cannot watch me now talking to you. Without research, you cannot have a mobile phone. Without research, you cannot use television, radio, or any other modern gadgets, including a laptop, video games, and everything. Any gadget as man has made is only because of purely based on research and experience. So in this context, as an undergraduate student, when you take up engineering as your career, you want to take up engineering as a career, it is a must that you should understand the importance of research. In the current scenario in India, 90% of the jobs are coming from service industries, like information technology service industry, or information technology enabled service industry, or manufacturing service industry, or pharmaceutical service industry. And only 10% of the industry in India is focused towards R&D and indigenous product development. That is, we make the product and sell to other countries. But most of the products that we use in our day-to-day life are either invented in the West and then bulk manufactured in China, and then we are just users. So as an engineer, as an aspiring engineer, if you want to take up research as a career, even in engineering, it is a must that you should know and have a passion for doing things. You should have passion for dreaming. You should have passion for doing things with hands, and you should know how to use your knowledge to create stuff, for how to apply your knowledge, how to apply your theoretical knowledge and create products. So basically, what is engineering? Engineering is the process through which the human species is able to build technology. So then what is technology? Technology is nothing but tools and crafts developed by human species for their own benefit and comfort. And then what is science? Science is basically the ability of human species using its 5 senses and the brain power, that is around 1400 grams in male and 1350 grams in female, to understand and analyze this universe around them. So that is the connection between science, engineering and technology. So an engineer should also have a basic understanding about the science so that he can develop very good tools and products, right? That is technology. So engineering is in the middle, connecting science with technology. So in this, if you want to perform research, a basic undergraduate degree in engineering is a must, and that is the starting point for you. So if you start with the engineering degree and not study for the sake of marks but for the sake of understanding, you will be able to take up research as you grow up. So you can go for a postgraduate degree, then for a PhD, whatever. But end of the day, engineering degree in India has become as a must for everybody, because many people think that you can easily finish a 4-year course by paying certain sum of money in a private or a government institution, then get a job in IT service industry. That has been the dream goal. But now we can realize that a service-based industries will always depend upon other countries for project, and that is what is currently happening in India. That when the visa restrictions and other things have come into play, we are realizing that we have to create our own technology instead of depending on other countries for projects and jobs. So because of automation, that is machine learning and artificial intelligence, many of the regular jobs in the IT industries has been replaced with systems and softwares. So for a young engineer, an aspiring engineer as on date, it is imperative that he has to understand the fundamentals, not for the sake of marks, not for the sake of placement, but look at a career. It is very well known fact that out of 100 people, only 20 or 30 may be interested in a research, but still research is very much important. Hello everyone, and today I'm going to talk about what are the future disciplines that you can take as a career as on date, as on 2017, in this particular month, May. If you look around us, there has been a lot in the newspapers and the government media agencies which have been talking about job loss in IT service industry, especially in IT enabled service industry and typical IT service industry. They are giving 2 factors. One factor is the emergence of machine learning and automation. The second factor being the visa restrictions. So these are the 2 important aspects which are given, the 2 main reasons which are given for the job loss in the current industry. So when you are going to join engineering or a technology program in the year 2017, what you can look forward to by the time you pass out by 2021 or 2022. So by that time, most of the technology would have been automated. Like when you were born, there was no touch screens, there were no conducting polymers. But today, each and every device that you use in your day-to-day life, or handheld devices to television, to any kind of electronic interface device, is touchscreen based. Okay? It is basically the emerging technologies which gives you a path in which you have to build your career or your passion, follow your passion. Like what you have seen in 3 Idiots movie, it is up to the passion which will take you as a career. And there is a lot of difference between a job and a career. Career is long term. Career is connected to your passion, interest, and what you want to do in life. And job is just for making money, a short-term happiness. But for any professional, you have to look up to what is going to happen in the next 4 years or next 5 years. When you pass out engineering in the future, most of the domains you'll be working on will be the product of the research done 10 years ago. What are the domains that you can look forward to by 2022 or 2025? The most important thing is going to be artificial intelligence. Traditionally, artificial intelligence is basically based on formal sciences, logic and mathematics. We started with neural networks, then it followed with machines which can learn from, or self-learning systems. And we also talked about traditional artificial systems like fuzzy logic. But this embryonic stage of machine intelligence, which has started in the last 40 years, has taken over all the industry within the last 6 months. So when you pass out, it is a must that you should have or a basic understanding in artificial intelligence, at least couple of tools or knowledge. So artificial intelligence and machine learning can be one area. What are the other areas you can look into? As the internet speed has increased after 1984 and how the computing process started in 1971, today we have more than 1 billion transistors in a small 1 centimeter square area for microprocessor in the die. And because of this high computational power and miniaturization, the speed of internet as through wireless communication has been very, very high. So most of the devices, that is living devices, non-living devices, able to communicate with the internet through sensors and actuators. So the network of all these automated devices by sensing and activation is what going to contribute to the Internet of Things or Internet of Everything. This is the second field. Third important field, as silicon semiconductor is going towards further miniaturization, we can see, for example, the CMOS inside your Intel microprocessor is now under 16 nanometer technology to 14 nanometer technology. In the near future, silicon, we will be trying to modify silicon to use at around 10 nanometer technology. So when you talk about 10 nanometer technology, the property of the silicon changes. So what else can replace electronics, or what else can work concurrently with electronics? In that aspect, we can talk about photonic integrated circuits. The photonic integrated circuits or photonics is going to be a parallel domain for electronics in the coming years. Already you can see the usage of photonic circuits, photonic integrated circuits, similar to your integrated circuits where electrons make the noise. In photonic integrated circuit, the light photons are responsible for the signal flow. So these big devices are already being used in Xbox to transport large amount of data from your Xbox user interface to the terminal, basically your television or a computer screen. So this is photonics as a domain is going to be a big money spinner in the next 4 to 5 years. Another important aspect is going to be self-driving cars, or what we can call intelligent transportation systems. So more and more companies will come, like Tesla, Google, many other companies are already into self-driving cars based on camera intelligence. But many of these cars are still in the process of including computer vision, that is artificial intelligence with camera. So this will become more sophisticated with the growth and the speed of processing speed. So more self-driving transportation systems, or self-driving cars, self-driving buses, self-driving vehicles will be on the roads in the next 4 to 5 years. What is another important domain? Another important domain is going to be satellite engineering. Traditionally, satellite engineering has been there from the first time the Russians launched the satellite into space from 1950s to the early 1950s. And India has the capability to launch with PSLV, we know about it, Polar Satellite Launch Vehicle, which we used to launch Mangalyaan and then even Chandrayaan to Moon and Mars respectively. But today in the latest technology, it is all about miniaturization. We have recently heard about the news where ISRO launched nano satellite less than 4 kilograms of 88 satellites together into the space. So satellite engineering, where swarming, based on swarming concepts, like group of ants, a swarm of ants, a swarm of ant hills, small animals moving around, or swarm of honeybees, similar to the small prototypes of less than 1 kg, what we call micro nano satellite, will be in the space in the next 4 to 5 years. So this is another interesting domain. Another interesting domain that we can talk about is alternative energy systems. We all know the fossil fuels are being depleted every day, right? So to replace these fossil fuels, we have been working with solar, wind energy, nuclear energy, etc. But now the competition is to come out with the storage equipments which can have less space but actually store maximum energy. So alternative energy system is another demanding topic where many of the engineers and researchers around the world and even companies are heavily invested. Companies like Tesla, for example. And any other domain that you may think that may change the world is one thing that you would have never imagined, that engineering and agriculture are going to play a very important role. So as the cities around the world become urbanized more and more, so we have to look at how our farm fields are being depleted, especially in India with the development in information technology in the last 30 years. Many of the fields, farm fields have become buildings or flats or housing boards. So these things have depleted the amount of hectares of land used for agriculture. So what is the alternative? If the alternative is digital agriculture, then what is digital agriculture? Digital agriculture is about combining technology with agriculture equipment and farm equipments. So that is another big revolution. You would have heard about aeroponics, hydroponics and aquaponics. These are the things which will be able to feed the huge populations which will increase in the next 5 to 6 years. Through technology, we can grow it in urbanized area also. We could have a huge amount of yield, that is tons of yield in a small area. So these are some of the domains which I have talked about in this video. The next video I will talk about research. Done. Okay. So I talked about different technologies. Another important technology that is going to revolutionize the whole world in the coming years is going to be personal manufacturing. You can all see here, there is a 3D printer here. This is a kind of a 3D printer which prints ready-made objects, something like this. Yeah. So you can print it. Before we have to make the mold in the manufacturing, in traditional manufacturing, we have to make the mold of the object that has to be manufactured in bulk quantities. But because of the evolution of 3D printers, it is possible to design the object in the computer, on the laptop, a 3D modeling, and directly print it. This is going to revolutionize manufacturing. This is also can be called as flexible manufacturing. The 3D printer is the foundation of the flexible manufacturing. 3D printer is like a robot. You can see that here. It has multiple motors in 3 different axes, x-axis, z-axis and y-axis. And these 3D printers can print objects of any complexities. Okay? Basically, the material to be printed is held like this. You can see the spindle here. This material is directly fed to the depositing head, where it is being heated, melted and then being poured out. So this x, y, z axis, basically it prints layer by layer, 3D printing. So x, y axis is the bottom and the height gives the z axis. So you can print any kind of 3D objects. Okay, that is the example. So this kind of technology is what going to revolutionize manufacturing. If you look at it, if you ask me whether it is mechanical, electrical or electronics, it is combined, it is an interdisciplinary field. No domain is a single domain because it has to come, it is the intersection of different domains like mechanical engineering, electronics, material science, okay, embedded systems, all of these things come together. Next important domain that we have to talk is about satellite engineering, which I already spoke in the earlier video. But satellite engineering is going to the next phase because there are 3 kinds of satellites based on weight. One is called bulk satellites or heavy satellites, which are in the tons of kilograms. Then we have micro satellites and the nano satellite based on the size. Okay, and these satellites are to be placed at different orbits: MEO Earth orbit, medium Earth orbit, low Earth orbit, or geo orbit, geosynchronous Earth orbit. These are different altitude from the surface of the Earth. So placing these satellites, using these satellites for communication, we are able to access the facilities like GPS. We are able to watch television at the home, the digital audio broadcasting and digital video broadcasting. So these are we are able to monitor the weather, we are able to observe the space by putting Hubble space telescopes, we are able to send spacecraft. All these things are possible because of satellite communication, or what we can generally call as space communications. Okay. As the technology develops more and more, as the electronics become smaller and smaller, that is the electronic components become smaller and smaller, and the size of the processor which is inside your computer becomes smaller and smaller. Even a simple mobile phone has high computing power. So the weight of the electronic that has to be carried from the surface of the Earth to the space has to going to be reduced. So this is going to help you to launch very nano sized, that is less than 2 kilogram or 1 kilogram sized object into space. For example, instead of sending 1 ton or 2 ton weight spacecraft to moon, it is possible to send hundreds of 1 kilogram satellite to the moon, each one focusing on one particular function. So this is another interesting area where many of the engineers can find futuristic jobs as well as build their career in space. Okay, cut. Hello everyone. Today, now I'm going to talk about the relationship between, you will see from my board, research, education and training. What is the connection between science, engineering and technology, and what are the different technology, and how engineering is related to science and technology. Right? Basically, I already described in my previous video about science. So science is the ability of the human species like me and you to use their human brain and the 5 different senses to understand what's happening in this universe around us, and what are the different phenomena happening, natural phenomena happening, understanding them, and then trying to observe what's happening in nature for their own use and purposes. Now, if we start systematically do it, then we define it as research. Okay, so systematic observation and systematic analysis called research. Now, research is the fundamental component for any kind of development, any kind of technology or engineering to be developed. They are all based on sciences. So we should also understand the basic difference between education and research. Right? Education meaning you are grooming a student to understand certain basic concepts. Training only comes into picture when we talk about skill set. For example, sensory motor actions. So basically, if I want to train a mechanic who can repair a bike or a car, we are going to train him on the skills where he has to learn how to coordinate his forelimbs and hind limbs to hold the spanners and different mechanical tools to fix an engine. That is training. Education means making the student or the participant or the individual to learn about the fundamentals and give them enough capability to think on their own and arrive at solutions. Right? That is education. Then what is research? Repeated search for solution is research. Repeated search. What you have to search for? You fix on a problem and you try to come to a conclusion based on different kinds of trial and error methods, whether that particular solution fixes that problem. That is one way of looking at research. Or just like that, you want to know why the leaf is green, so you go deeper and deeper and try to do analysis, or how the car works. How can I build an engine similar to the car engine? Or how can I build a telescope which is similar to a Hubble Space Telescope? Or how can I look at the stars, or how the stars are working? So it can be theoretical or applied research. Basically, in India, we have been very good theoretical researchers for a long time. So we were the inventors of zero. But in the last 200 years, we have not been able to produce or manufacture or invent any kind of devices or systems that we use in our day-to-day life. For example, we never invented the computer. We never invented the mobile phone. We never invented the aircraft in the last 100 years. But we have been using them continuously, right? Especially in the last 30 years, India has been very, very successful in the IT sector. But IT sector is also currently going down because of development in technology. So what is technology then? So technology, as I explained previously, is the ability of the human species to develop tools and crafts for their own improvement in their living standards or comforts. Technology means application. It comes from the Greek word technica, which means application development. Right? So there are only 4 broad areas of technologies in this whole universe as man-made. One is how to collect information and process them, information technology. The other one is biotechnology, where we use the biological entities like cells, plants and other things to come out with new application which can work, like food processing technology, or jam or a pickle which is stored in the jar. These are preservatives, studying about and learning them, or how to use bacteria for fermentation. That is biotechnology. Then comes the nanotechnology, or we can call material technology. We are trying to exploit the nano-dimensional properties of matter to come out with new devices and systems. That is nanotechnology. Then the last but not the least is the cognitive technology. Cognitive technology in the broad sense encompasses every area which tries to replicate the cognitive abilities of human brain. So that is cognitive technology. You can replicate a neuron functionality. You can replicate the central nervous systems to interconnect. For example, today we are working on how to interface the brain, how to interface the human brain with the digital systems. So there are many ways and techniques in which you can do, like functional magnetic resonance imaging, or you can also do with optogenetics, or you can also do with electroencephalogram. Okay, there are many other techniques through which we can interface the brain with the digital systems. So this area is cognitive technology. Then what is engineering? Engineering is the process of building this technology. So basically, it is the design and construction. Engineer means one who constructs. So there are only 4 basic engineering areas. One is electrical, civil, second is civil, third is mechanical, and fourth one is chemicals. So all other disciplines in our country, like electronics and telecommunication, electronics and instrumentation, all these things have been coined only for specialization to increase the employment, skilled employment, right? But generally we have only 4 areas of engineering. So using these 4 years of engineering and 4 areas of technology and 2 basic sciences, what everything around in and around us has been based on these 6 things only. Okay? Then we have to understand the difference between education and training. So I already explained about training. Training is about using your sensory motor actions to use tools and devices to fix a problem. That is skill-based learning. The other one is educating, where you provide the basic knowledge for an individual so that he can use his own capabilities to develop systems or to fix up problems or develop new kind of idea or a new theory. So in our country, there has been always focused on skill-based training for employment. So recently we have seen the many boards for NSDC, National Skill Development Council. But engineering is a domain which is a combination of skill as well as knowledge. You cannot segregate both of them, and also you should have very good understanding of the science. As more and more development is taking place in terms of the computing power, controlling power and communicating devices like handheld devices like mobile phone, touchscreen based mobile phones, all these developments are growing at a very fast pace. But 16 lakh engineers are passing out of India every year. Not everybody is finding jobs because they are all getting degrees for the sake of degrees or to just have a paper. And most of them dream to be a part of the software industry. But recently the software industry is also not to employ all the 16 lakh engineers who are passing out every year. So what should be your focus? How should be an engineer? Who should become an engineer? An engineer is the one who has the passion and who has the ability to connect science with technology and who is able to apply his theoretical knowledge to construct systems and devices. So that is a real engineer. And what is the most important quality an engineer should have? All he needs to have is imagination and creativity, nothing else. It is not a must everybody should be smart in mathematics. It is not a must everybody should be good in programming, because today from a school children to a PhD level or any postdoc level or a scientist or a Nobel, or irrespective of their qualifications, everybody should have some minimal programming languages. So just by using programming language, or the skill to use a programming language is not going to land up everybody in a job. So what you have to do, you should be able to understand the difference between a product-based industry and service-based industry. As an engineer, you want to be an R&D engineer, or you are just happy to fix a bug and then get paid off as a job, which is normally temporary basis. A career is a long-term basis. So it is not a must for everybody to become an engineer and doctors only. You have to just follow your passion. If you are good in dancing, go ahead with dancing. If you are good in singing, go ahead with singing. But today, more and more industries require more multi-talented or multi-talented people or multitasking people who are jack of many trades but at least master of one trade. That is, if you have a basic solid foundation in engineering, then you can apply that knowledge to other domains to bring them together. That is what we call it as convergence of technology. Basically, convergence of technology is where information technology, biotechnology, nanotechnology and cognitive technology, all of them come together to give a product. Very simple example. Many of you would have seen your parents or in your house and hospital nowadays we use portable glucose meter, right? See, this portable glucose meter has an embedded controller in LCD display, and you are putting a drop of blood and it tells you the amount of sugar. But it is a combination of biotechnology, information technology, specifically embedded system, and also materials technology, the display, the plastic, everything. So it is a combination of different technologies which allows you to have one particular product. For example, today you are able to watch cricket match or a football match live on your mobile. This was not possible 20 years ago. That is also because of the development of the wireless communication, the miniaturization of the mobile phones. Mobile phones were so big, now they become so small. So all this development has now come to the next level where the artificial intelligence is taking over. So we had mechanization in the early 19th century, that is with the James Watt's engine. We had the engine. From there on we went to electrical engineering when the electricity was there from late 18th century. Then they started being using by Thomas Alva Edison as a DC current and by Nikola Tesla as an AC current. And then by 1947 with the invention of transistors, there was a dramatic change in electronics. So then the automation went to the level of using electronics to automate the functions, like what they did with from a bullock cart or a horse cart. They went to a steam engine, from steam engine using electrical power, electrical engines. Then came electronics which allowed to control all these things automatically. Then by 1971 the Intel microprocessors were invented, which had 1000 transistors with 1 MHz operations. and that revolutionized the whole computing technology. Today, we are on the verge of where artificial intelligence, especially machine learning, is taking over all the automated services that are to be provided by the different services and industries. Next major breakthrough has been the connectivity, which is internet. So internet has been able to connect different people, different systems together, and the speed of internet also has increased over the years. Not just fiber optic based communication, even a wireless communication. Today we are able to access 4G, fourth generation internet services in India with very high Mbps capabilities. So all these have been possible only in the West. Why it is so many things are not invented in India? Why it is that no more television is invented in India? Why there's no modern gadgets invented in India? Yes, we have been very successful, maybe at 10%. ISRO is very successful, or some of our scientists who leave this country are very successful. But why none of the products that we use in our day-to-day life is not invented in India? Because even we have IITs, we have many Nobel laureates who worked outside India, we have many agricultural universities, we have many colleges and schools, and lakhs of students are passing out, at least 1 crore of students passing out every year from 10th standard, 12th standard, undergraduate engineering, medical law, everything. But still we are not able to find solution to our own problem. Even today there are many farmers who commit suicide in different states in India, like Vidarbha, Rajasthan, Tamil Nadu, which are all dry areas where water is scarce and there is a problem of water. But why can't we come out with some plants which can grow in this dry climate? Why can't we invent or discover a new species which can combine the different properties and do that? Why is that we have to always chase the developed countries for fixing our problems? Why is that no engineer, with 16 lakh engineer coming out every year, why there is no invention or a low cost motor which can draw water from deep down there, which can be used in areas like Vidarbha, Tamil Nadu, Orissa, or Rajasthan, where the water level has gone down? Why is that we are not able to fix our own energy problem? Why is that we are not able to develop ships or aircrafts? We are buying for 54,000 crores aircraft from France. Why can't we invest that 54,000 crores into the research and development, invent our own aircraft and sell it to France? So that is the way to think. If you want to be a superpower, if you want to be a powerful country, not in terms of war power, but in terms of technology super. Whichever country is ruling this world is technology superior. Who invents more? Who necessitates requirement of tools and crafts to improve your standards? These are the countries which lead from the front. The countries which are dependent on them have to always follow back. It is not that we have not achieved, we have achieved, but that is only achievement of 10% of the populations who are very passionate and they have contributed to this country. Remaining others just migrate or just very happy with a routine job in their life. So why can't engineers transform the world? Why can't the Indian engineers bring out with new systems, new devices, right? So this domain gives an opportunity for you to apply your skills, apply your knowledge, and come out with innovative product and solution which can help this country grow in the future. Enough?